Hi, this is Craig Stocks. I did a video a couple weeks ago where we used this image of Orion to illustrate how to put an image together using narrowband hydrogen and oxygen data. And we did that by creating a starless version of each layer, the hydrogen and the oxygen. And we did that for a couple reasons. One, it let us extract the stars so that we have a third layer with just the stars on it. And then we can selectively turn that on and off, but more importantly, we can selectively edit the underlying layers and stretch that in data to make it brighter or more contrast or whatever it needs without affecting the stars. And one of the problems we frequently run into is the stars get bloated as you try to stretch the underlying nebula data. So that avoids that problem. If you haven't seen that video, I would encourage you to go back and look at it. One drawback of the approach we used of using the calculations method is that it doesn't preserve star color. And that's fine with a narrowband image where you don't have star color to start with. But if you're starting out with a full color image, which I have here, I do have some color in the stars. Now this is a somewhat finished image. It has visible color data in the main nebula of Orion and the Running Man Nebula, and some hydrogen alpha background information added. But the point is, if I want to work on the layers here, I want to extract the stars from the background, but I want to preserve the color. And the problem you run into is when you create that starless layer, and this is the starless layer, so I've gone through and used the noise and scratches filter plus the healing brush and the spot healing brush both to clean up the stars and create a nice clean starless layer. The way we did that before was to use the calculations tool. And first let me create a blank layer that we'll put it on. I'll go to calculations, and what I want to do is subtract the starless version from the original. And I want to use a blending mode of subtract. The problem is it only does it one channel at a time. You can choose the red channel, the green channel, or the blue channel, but you're only getting one channel. And in a monochrome image, all three channels are going to be the same. Red, green, and blue are all the same, so it doesn't really matter which channel you use. If you're working with a grayscale image, there is only one channel. But when you're working with a full color RGB image, that if I extract the stars and I have that layer here, it works very nicely. You get a layer with just the stars on it, and let me alt click on that. There's the layer with just the stars on it. The problem is I've lost the color that was in the stars. If we look at the original version, there was some subtle colors in those stars that we lose when we use that method. So here's an alternate method you can use, and let me get rid of this blank layer since we're not using it for anything, in order to create this starred layer. Now for this to work, I need a flat layer that has my base image on it. So if this were made up of a number of layers, I would need to create a stamped layer that has just a single layer that has the stars in the background and everything. And then right on top of that, a single layer that has just the nebula without the stars, where we've already created that starless version. And the way to do this and retain the colors is to go to the blending mode of the starless layer and choose subtract. And that does the same process as the calculation. It subtracts the starless layer from the star layer, and the only difference is the stars, so it leaves just the stars on their own visible layer at this time. The problem is this isn't really a star layer. This is a starless layer in subtract mode, and we really want to put this on its own layer so we can use a lighten blending mode. And we can't use both a lighten blending mode and a subtract blending mode at the same time. So we want to create this as its own layer, and you can't rasterize this, but what we can do is create a stamped copy of all visible layers, which right now, this is the result of all visible layers. On a Windows computer, if I do Shift Control Alternate E, and you would use the Command Option Shift E on a Mac, that will create a stamped layer of all of the visible layers, and that's what's on layer 1 now. The advantage of that, though, that's just in normal mode. So let me turn that off, and we'll come back to our Starless layer, and let me put it back in normal blending mode. So we now have this Starless layer, and if I turn it on, it just overlays everything. But if I put it in linear dodge blending mode, what that does is add back everything that we just subtracted. It's basically an addition process. And so now we have our stars, and we have the colors in the stars on their own layer. So I can now use various curves, levels, whatever I want to do to work on this starless nebula layer. By clicking the little icon here, I can clip this curves adjustment to the layer just below it. So it's not affecting any other layers. I could brighten, darken if I want to brighten the background, darken the nebula, whatever it is I want to do. I can work on that in the curves, and it's not affecting the stars at all. Also, I may want to adjust the stars independently. So I might want to also add a curves layer and clip that to just the stars layer. And one thing I might want to do is pull the blacks in to be sure that we're not affecting any of the background. And then I can adjust the brightness, which winds up affecting the size of just the stars independently from the background. So it really gives you a lot of power and flexibility in how you go about editing. Using this approach, you're able to subtract the stars by subtracting the starless layer from the original, leaving just the stars on their own layer, and preserve the color in the stars in the process. That's my tip for today. If you know of a better way or a different way to do this, please leave a question in the comments, and thank you for watching.